Good day and welcome to our statistics and probability class. In this video, you will be learning lesson number 1 in module number 1, random variables and probability distribution. Let this be your guide in answering the module. Okay. Random variables. Let us try to understand what is this random variables. Let us try to dissect these two words, variables. So when we are talking about variables, it is used to measure one's characteristics. For example, characteristics of a person, characteristics of a thing, an animal, or anything that is being observed or that is being used in a research. That is what we call variables, measuring one's characteristics. Random. Of course, we know that random doesn't follow a pattern. Yeah, let us have a real life example of random variables that we always have in our daily lives. For example, we always fall in line. Everywhere we go, we fall in line. When we go to church, to school, to supermarket, or anywhere that we go, we are patient in falling in line. So, for example, in a bank, they are recording the customers, the people that are entering in their building, in their establishment, to keep a record for them to improve their customer service. And then um, that is an example of a random variable because they do not know who will come in, go inside their establishment. If it is a woman, a man, a kid, an old woman, or anyone could enter. That is an example of random variable. We do not know who or what will come or what will happen. Another example and the common one is when you are playing a lottery game, the lotto. Yeah, I know you are familiar with the lotto. You want to win, of course, and of course you need to buy that ticket with 6 numbers combination. And then did you know, I mean, just a trivia, there are 13,980,000 and more combinations of that game, no, of that six uh, numbers game. So if you're going to have only one ticket with one combination out of 13 million combinations, of course, you have only a very little chance that you are going to win that lottery game. Yay, so that is what we are going to know in this lesson. We are going to have that exact estimation. We are going to list the possible outcomes that might happen, that might occur when we are having that probability. Okay, so let us be guided with these questions. Hopefully you will be able to answer all of these questions after this discussion. So what is random variables? What is difference between discrete and continuous random variable? How do we construct probability mass function of a discrete probability distribution? Ayan, this is what I am talking about. We are going to list all the possible outcomes, even if we do not know what will happen, what will occur. But here in statistics and probability, we are going to list all the possible outcomes because um, for us to know if what percentage of chances or probability that we are going to have um, that desired outcome that we want to have. Okay, but first let us have a review on probability. This is a lesson in your junior high school. So probability is a measure of chance declared through reasonable opinion. Okay, you want to know the percentage that you are going to win that game, going to win the heart of your the one that you are courting with. For example, that is the probability. Yeah. So given a random experiment, so once you are doing the game, lottery game, recording all the people that are entering in your establishments, those are examples of random experiment. Then the set of all possible outcomes is called its sample space. Each outcome may be referred to as a sample point. Let us have this example. Let's say that you and your friend are playing a game, the tossing of a coin. And we know that a coin, for example, 1 peso bill, has two faces, the head and the tail. So that is what we call the sample space, denoted with the set notation S is equal to heads and tails. And each of the element is uh, called the sample point. Sample point. Yeah. And we also have another example, rolling a die. So we know that a die has 6 faces, so we call it, so they have the sample space is equal to 1, 2, 3, 5, 4, 5, and 6. That is rolling a die. And then we also have this another term here, the event, or denoted with the letter E. Yeah. For example, you are going to win the game if the upper face of the die will be an odd number. So that is what we call the event. The same also with the example here with the heads and tails. If you are going to get a head on the top, then you are going to win the game. That is what we call the event. While the sample space is all the possible outcomes. I hope you understand that very well. And for us to compute the probability, very simple formula. You're just going to have probability is equal to event over sample space. So in rolling a die, what is the probability that the outcome is odd? Okay, let us have the solution. Of course, we know the given. We have the sample space. There are 6 faces, and out of those 6 faces, there are only 3 odd numbers: the 1, 3, and 5. So that is the number of events that you're expecting to get. So you're just going to divide event over sample space, which is 3 over 6. Then you will have 0.5. Therefore, you will have 50% chances that you are going to win the game. Simple as that. That is probability. Event over sample space. Let us have more examples. To determine the probability of heads, a student tosses a coin 100 times. Of these, 53 turn up heads. Hence, he concluded the probability of getting a head is 53 over 100, because there are 53 events, and then out of 100 sample space, ayan, then the probability is 0.53. Therefore, 53% chances that you will have the head. Okay, another example, a store manager kept data of the number of customers who comes in the store and make a purchase. Of the last 875 customers, 366 actually bought something from the store. Hence, he concluded that a customer who comes in the store has a probability of 366 over 875, because out of 875 customers, there are only 366 customers who bought something. Ayan. So others are just having a visit or a window shopping. So there is a 42% probability that that a customer will buy something when they enter the store. Okay, so you may have a fraction form or a decimal form when you're asked of the probability. But most commonly we are using the fraction form. Okay, let us have another uh, quiz or exercise so that you will really master in doing or solving the probability. So you may pause the video if you want to guess the answer. Okay, we have this question. A bag contains 5 blue, 12 green, 9 red, and 4 yellow marbles. What is the probability of pulling a green marble out of the bag? Okay, so what do you think is the answer? So let us try to solve this one. So we need to find the event. So the event here is the green marble. So there are 12 green marbles. And then let us try to add the sample space. So 5 blue plus 12 green, that is 17, plus 17 plus 9, 17 plus 9, that is 26 plus 4, that is 30. So there 12 over 30, that is equal to ayan, 0.40 or 40%. Another example. What is the probability that the spinner would land on A? And that the spinner, wheel of fortune, will land on A. So as you can see, there are 3 A's out of how many portions? You have 8 portions. So 3 over 8, that will be equal to 0.375. So the answer is letter A. Another example. The pet store has 8 dogs, 3 cats, 2 hamsters, and 4 fish. What is the probability that a customer will not pick a dog? So the customer will not pick a dog, only the cats, hamsters, and fish. So you are going to add all the events. 3 plus 2 plus 4, and that is 9. So you will have, okay, 9 over, you're going to add 9 plus 8, that is 17. 9 over 17, that is 0.53 or 53% multiplied by 100. Okay, let us now proceed to another concept. So I hope you were able to be refreshed with this discussion about probability, because we will be using this lesson in constructing probability mass function in our next lessons. Okay, let us have the discrete random variable and continuous random variable. Okay, so these are two types of a variable. We can also categorize it in a data, but that is another thing. But this is um, variables. Okay, so discrete random variable is used for counts. When you are counting things, objects, or people, or anything that you are counting, it should not have a decimal. For example, number of heads in tossing coins, sum of outcomes in rolling dice, number of population of some object. For example, in your household, there are 4 members in the family: your mother, your father, you, and then your younger brother, for example. So you only have 4. You cannot say 4.5. There are 4.5 members of the family, because you cannot have a decimal, because your reason maybe is you have a younger brother Siguro, for example. So that is not an example of a discrete random variable. Again, discrete random variable, discrete, that is used for counting, no decimals, whole number. While the continuous random variable is the opposite, of course. You may have a decimal point, or it is in a fraction form. For example, the time, you can say 5 hours and 2 seconds, something like that. Length, area, volume, mass, and wave, and many more. Let us now go to our main topic of this discussion. This is what we call the discrete probability distribution. Let us try to construct this probability mass function. Let us have this example. Let's say you are flipping 3 coins at the same time. You have 3 coins. Flip at the same time. And then let random variable x be the number of heads showing. We are going to list all the possible outcomes out of these 3 coins being flipped all together. So we are going to use random variable x. So we have the list here of the possible outcomes. The first coin may be having the head, and then the second one is head, the third one is head. You are the luckiest if you have that combination. And the second combination, you can have head, head, and then the other one is tail, and so on until you'll have T, T, and T. You are just going to list all the possible outcomes, and then as you can see, you have the pattern so that you will be guided. Okay, and then you are going to count, since we are looking at the random variables. I mean, looking for the random variable of x. So you will have 3 heads in this combination. You will have 2 heads, 2 heads, 1 head, and so on. And then here, this is what we call the probability mass function in a tabular representation. You can write it here in a table. Okay, so how many zeros can you see in this set of combinations that you have? There is only one. So you're going to write it here, 1 over 8. Okay, by the way, we call these variables as the random variable x. Okay, this is in a set form, 0, comma 1, comma 2, and 3. Okay, no need of repeating the numbers. You're just going to list all the random variables. You are going to indicate it here, the number of repetition. Here, there are 1 over 8 because there are 8 combinations, 1 over 8. Next is 1, next uh, is 1, so you will have 3 ones, 1, 2, and 3. So you'll have 3 over 8. Next is 2. So how many twos can you see? There are 3. So the same, you will have 3 over 8, and then 3, you will only have 1 over 8. So this is now what we call the probability mass function represented in a tabular form. And then here is the main property of this discrete probability distribution. If you are going to add all these fractions here, okay, you're going to add all these fractions here. Since this is similar fractions, so we're just going to add directly the numerators. So we are going to add 1 plus 3 plus 3 plus 1, that is 8 over 8, or equal to 1. A discrete probability distribution should always be equal to 1 or 100%, right? It is just like you're having the percentaging, or what we call the probability. So discrete probability distribution should always be equal to 1. Okay, and then probability distribution can be denoted with this function. P of x is equal, this is random variable x, is equal to the normal x. So it can be expressed in a tabular, graphical, or in a formula form. This is an example of a graphical. You're going to graph it. How many zeros? There are 1 zeros. How many ones? There are 3 ones, and so on. You are going to create a histogram. And this is a probability distribution in a formula form. P of x is equal to, this is a piecewise function, so 1 over 8 if x is equal to 0 comma 3, if you will have these variables here, and so on. Okay, in the test or in the exams, you might be asked if this probability mass function that we have here in a tabular form is if it is a discrete random variable or not. So it is very easy for us to determine if it is or if it is not. We are just going to add all the random variables, 1 over 3, 1 over 3, and so on. If it will be equal to 1, then it is a discrete random variable, but if it is not, then it is not a discrete random variable. Very obvious. If you're going to add 1 plus 1 plus 1, it will be equal to 5 over 3, and that is not equal to 1. 5 over 3, 5 divided by 3, that is 1 point something. Another example is this one. P of x is equal to x over 6 for x is equal to 1, 2, and 3. So if you are just going to substitute all these values of x here, so 1 over 6 plus 2 over 6 plus 3 over 6, so 1 plus 2 plus 3, that is 6 over 6, right? I hope you can compute it in your mind. No? So you will have 1. Therefore, you will have discrete random variable. Let us have another example so that you will really understand deeper this concept. So an experiment consists of rolling a pair of dice. So there are 2 dice. And then let y be the random variable representing the absolute value difference of the numbers that come up. So absolute value, it is always positive, and then the difference you have a die here and another die here. If you're going to combine these two, for example, 6 and 5, if you're going to subtract, because this is difference, subtract 6 by 5, then you will have 1. For example, 5 and 6. So 5 minus 6, you will have negative 1. But since this is absolute value, then you will still have 1. Okay? So we are asked to construct the probability mass function of y and draw the corresponding probability histogram. So here is as the solution. So again, we have the first die in rows and second die in columns. So we are going to combine, for example, 1 minus 1, that is 0, 2 minus 2, that is 0, and so on. So in all, there are 36 possible pairings. Very simple lang. 6 times 6, of course, that is 36. So if we're going to list all of the differences, then you will have this one shortcut. There are, how many zeros can you see here? 1, 2, 3, 4, 5, 6. So there are 6 here. List also 1. How many ones can you see? Not including this faces. This is just the faces, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you will have 10. And so on. You're going to count all of these variables. And then we are going to have the over. 6 over, okay, 6 over 36. But since we know that if it is a fraction, it should be simplified. So we are going to simplify 6 over 36. So simplest form of that one is 1 over 6. Next is 10. 10 over 36, that is 5 over 18, and so on. And then if you want to check if it is a discrete probability distribution, then it should always be equal to 1. Ayan. So, of course, if you can use your calculator, this will be equal to 1. And then if you are asked, what are the values of random variable y? You are just going to list 0, 1, 2, 3, 4, and 5. These variables here. And this is an example of a probability histogram. Okay, let us sum it up, all the lessons that we learned in this video. So a random variable is a discrete random variable if its set of possible outcomes is countable. It should only have that countable numbers. You cannot use decimals in using discrete random variable. That is another lesson in in continuous random variable. So such as number of defective chairs produced in a factory. That's an example. So a random variable is continuous random variable if it takes a continuous scale such as heights, weights, and temperature. It has decimals. Properties of probability distribution. So the probability of each value of x is a value between 0 and 1. Okay, value between 0 and 1. Because no, if you're going to sum all the probabilities, it should always be equal to 1. That's it for our lesson number 1, random variables and discrete discrete probability distribution. Thank you so much.